Okay, so now let us see some questions related to the work and energy. We have discussed its concepts. Okay, now let us solve some questions, interesting questions. So the first question is, look at the activities listed below. Reason out whether or not work is done in the light of your understanding of the term work. So there are some of the activities listed there, okay, some of the things, some of the actions listed, and we have to identify that whether the work is done in those actions or not. Okay, this is we have to determine, we have to identify this. Now for that it's very important for us to understand that what exactly is work. Work means simply when there is an application of force and that force is causing some displacement in its direction. Okay, so what is work? Work is basically the product of force and displacement, but the displacement should be either in the direction of work or in the opposite direction. Okay, if it is perpendicular to the force, then no work can be calculated. Okay. So for that, let us first write that what is important, what is work done, what are the conditions that work done, the conditions in which we can say that work is definitely done. So I will say first condition is that application of force, there must be some application of force. Second condition, if we talk about, then the second condition is displacement in or opposite to the direction of force. Okay, either the displacement is in the direction or in the opposite direction of force. So the first statement is Suma is swimming in a pond. So the statement you can see, it's Suma is swimming in a pond. So we need to identify whether the work is done here in this condition or not. So now, as we told you, as we have discussed, that work done will be when there is an application of force and when there is a displacement. Now imagine a person swimming in the water. What will happen if he is swimming in the water, he or she is swimming in the water? In that case, he has to apply the force using his hands, okay, to push himself, okay, towards in the forward direction, okay. So whenever you are applying, whenever you are trying to pushing yourself in the forward direction, it means you are pulling back the water, okay, and water is pulling you in the in forward direction, okay. This is like swimming happens. When you go inside the water, what happens? You start pushing the water in the backward direction, okay, and as we know, there is an action and reaction, okay, in the Newton's laws of motion, the action and reaction. If you are pushing the water back, then water will push you forward. So definitely here Suma has to apply force, okay, Suma has to apply force for the swimming, and we can see when she is applying the force, and whenever she is applying the force, she is moving in the forward direction, it means there is the displacement. So whenever there is the force, we can say work can be done. So first condition is satisfied that she is applying the force, and then the second thing, there should be displacement in the direction or opposite to the direction. So Suma is applying a force like this and water is pushing Suma in the forward direction. So what we can say, the force applied by the Suma is in the backward direction while her displacement is in the forward direction. So definitely there has to be work done. So in the first condition we will say, in the first statement we will say the work is done by Suma. Okay, Suma is doing some work while she is swimming in the water, she has to do some work. Now the second is a donkey is carrying a load on its back. Okay, second condition is when there is a donkey is carrying a load. So the second condition, see, let us suppose this is a donkey and this donkey is moving in this direction, okay, and it is carrying a load of mass m. So what you can see, the donkey is moving forward, it means he is applying the force to move in the forward direction, okay. So the direction of force is this horizontal, and the displacement, okay, if I talk about the displacement, this is the force that is applied by the donkey, but for moving, okay. But since he is carrying the mass at his back, so to keep on carrying the mass at its back, the donkey has to apply a force in the upward direction, because the mass is having a force of mg in the downward direction. So definitely the donkey has to apply a force F, which is equals to mg, to keep on carrying the mass. Okay, I'm carrying something in my hand, so I have to keep on carrying this. For keep on carrying this in my hand, I have to apply a force in the upward direction, so that it matches the force applied on this object due to gravity. Okay, so these two forces should be equivalent. So that's why I will say that the direction of force would be this one in case of mass. Okay, in case of mass we are talking about. Okay, and the donkey is moving in this forward direction. So what we can see, displacement and force, this is the displacement and this is the force. So force and displacement are perpendicular, hence no work will be done. No work will be done. There would be no work in this case. Then the third case, a windmill is lifting water from a well. So there is a windmill which is lifting water from a well. So what we can see, for example, this is a windmill, okay. These are, okay, this is something like a windmill, okay. Now here there is a rope tied, which is tied to another end of a bucket like this, and this windmill is carrying the water out of the well. So what exactly this windmill is doing? Windmill is pushing, windmill is trying to push this bucket in the upward direction. So this is the direction of force. And what is the direction of motion of this particular bucket or water? What is the direction of motion of the water? We can see that water is moving again in this direction. Okay, the displacement is also in the same direction. So we can see that force and displacement are in the same direction. So definitely we will say work is done by windmill. So definitely here the work has to be done by the windmill. Now the fourth condition, it says a green plant is carrying out photosynthesis. Now as we have learned, the condition for the work done has to be force and displacement both. Now in case of photosynthesis, we can see there is no displacement of leaves. When the food is getting prepared inside the leaves, have you ever seen that leaves are moving here around? Okay, no. So what does it mean? It simply means that no displacement of leaves occur. Okay, it simply means no work done. No work can be done when there is no displacement. Okay. Now the next is E. An engine is pulling a train. Now an engine is pulling a train means this is an engine. Okay, let us suppose this is an engine. This is pulling a train at the back. This is a train connected like this. Now engine is pulling in this direction. Okay, so this is the force, this is the direction of force, this is the application of force, and the train is also moving in the same direction. So we can see force and the displacement both are in the same direction, so definitely work is done by engine. So it simply means that engine has to do some work to carry out this load. Okay. Now the next one, food grains are getting dried in the sun. Now when you are drying the food grains, does it happen that food grains move here and there? No, food grains are kept at a position. Even though we are drying them, there is no displacement, hence we will say no work done because no displacement of food grains. Okay, no work will be done because there is no displacement of food grains. Then the next is a sailboat is moving due to wind energy. So in the next case, a sailboat is moving. So this is the water. There is a sailboat like this. Okay. The wind is pushing this boat in the forward direction. So this is the direction of application of force. Okay. Because if wind is blowing like this, it will push the boat in this forward direction. And similarly, the displacement of boat will also happen in the forward direction. So definitely here work is done by the wind. Okay, definitely the work has to be done by the wind. Okay, so this completes the first question. Please note this. Okay, so now let's see the question number 2. It says a force of 10 Newton acting on a body at an angle of 60 degree with the horizontal direction displaces the body through a distance of 2 meter along the floor. Then calculate the work done. So in this question, what is given that there is a body, okay, this is the ground, let us say, and this is a body, and this body on this body there is a force of 10 Newton which is at an angle of 60 degree with the horizontal. So basically this is our horizontal, okay, this is the horizontal line, and the force is acting 60 degree toward on the horizontal to so that it can displace the body. So what I can see, that force is applied in like this, something like this, 60 degree with the horizontal, and this force is of 10 Newtons. Now observe here, what we want to do is we want to calculate that if this body gets displaced by 2 meters, if this body gets displaced by 2 meters, then what is the work done? Now till now we have learned that basically in case of work done, we talk about that force and displacement should be in the same direction. Here we can see the direction of displacement is this one, like this, okay, this is the displacement S. So here the force will be, the work done will be force into displacement into cos of theta, that is theta means the angle between force and the displacement. This is our F and this is our S. So we can see that force is 10 Newtons into S is 2 meters into, now cos theta, that is cos of, we say 60 degrees. Okay, in the mathematics we have learned about trigonometry. Okay, these are called the ratios, these are the trigonometric ratios we call it. Okay, so tan 60 degree, cos 60 degree is basically 1 upon 2. So solving this you will get 10 joules. Okay, so 10 joules is the work done by this force to displace this body. Now moving to the next question, it says a force of 5 Newton acting on a body at an angle of 30 degree with the horizontal direction displace it horizontally through the distance of 6 meters. Then calculate the work done. So here what is given in this question? It is similar to this question, question number 7. Here we have a body, okay, on which the force is acting at an angle of 30 degree and the magnitude of force is 5 Newtons, okay, and this force displaces the body by 6 meters. So the displacement of the body by this force is basically 6 meters. Now we can see the displacement is in this direction S, and this is the application of force. So again I can write that work done is equals to force into displacement into cos of theta. Now F is 5 newtons, S is 6 newtons, 6 meters, and cos theta, that is cos of 30 degrees. Now what is cos 30 degree? It is 5 into 6 into root 3 upon 2. Okay. So when you solve this, 3 2 times 6, and it will give you 15 root 3 joules. Okay. Now a question arises that should I solve this root 3 as well, or should I keep the answer in this format only? So I will suggest you should keep the answer only in this format. Okay, it won't be required to multiply this 15 by solving this root 3 as 1.732. Okay, it is not required. You can simply write the answer in the terms of root 3. This is the second and third. Now moving to the fourth question. Sorry, this was third question. Now moving to the fourth question, it says a body of mass 2 kg is moving with a speed of 20 meters per second, then find its kinetic energy. So in the question number 4, what we have to do, we have to find out the kinetic energy of the body when its mass is equals to 2 kgs and velocity or the speed is equals to 20 meters per second. So we know that kinetic energy is equals to half of mass into square of the velocity. So this is half into mass is 2 kgs and square of the velocity is 20 square. When you solve this, it is half into 2 into 400. So this comes out to be 400 joules. Okay, this is the 400 joules to calculate. This is the kinetic energy. Okay. Okay, so please note this. Now moving to the question number 5, it says a moving body of 30 kg has 60 joules of kinetic energy, then calculate its speed. See, question number 5, it says a body is moving with a kinetic energy equals to 60 joules and the mass of the body is given as 30 kgs. So we need to find out what is the speed of this body. So kinetic energy is equal to half mv square. We can see that kinetic energy is 60 is equals to half into mass is 30 and square of velocity. Okay, this 30 goes 2 times here. So 2 into 2 equals to v square. So the value of v comes out to be 2 meters per second. This is how you can calculate the velocity. Okay, it's simple question. You can easily solve out this question. Now moving to the next question, it says a hammer of mass 1 kg falls freely from a height of 2 meters. Okay, there is a hammer which is falling freely from a height of 2 meters and its mass is 1 kg. First thing is calculate the velocity. Okay, first thing you need to calculate is the velocity with which this object is traveling. Then second is the kinetic energy of the hammer just before it touches the ground. Okay, just before it touches the ground, that is the kinetic energy we have to calculate. And does the velocity of the hammer depend on the mass of the hammer? Okay, so try to understand the question. It says I am dropping a hammer from a height of 2 meter which is 1 kg. Okay, the mass of hammer is 1 kg. I want to find out its velocity. Okay, I want to find out that with what velocity basically does the hammer is falling. Okay, and then I have to calculate that what is the kinetic energy of the hammer just before it touches the ground. So see what situation it is given. From a height of 2 meters, this is a hammer of 1 kg. Okay, let us say this is the hammer. I am dropping this hammer, okay, of 1 kg down on the ground. I can see that at this point of time, we can see when the hammer was 2 meters up from the ground, its energy was potential energy, which is mgh. Okay, mass is, you can see mass is 1 kg into g, we can take 10 and height is 2, so that is 20 joules. Okay, 20 joule was the potential energy. Now, as soon as it reaches the ground, what is happening? Just before reaching the ground, its potential energy will go to 0, and everything means total all the potential energy will going to be converted into kinetic energy. Okay, so let me write here, just before reaching ground, the potential energy will get converted to kinetic energy. Okay, the potential energy will get converted to kinetic energy. So at this point of time, just before reaching the ground, at this place I will say that there will be a kinetic energy which is equals to half mass into square of the velocity. So what I can write is, what you can see that potential energy will be equals to kinetic energy at this point, because all the potential energy get converted to kinetic energy. Now potential energy is mgh is equals to half into mass into square of the velocity. Now here you can see the mass will get cancelled, g is 10, height is h is 2, and this is equals to 1 upon 2 v square. Okay, or let us see, we can see that this 2 will come here, so velocity will become 2 root 10 meters per second. Okay, this is the velocity, 2 root 10 meters per second. Now the velocity we have calculated as 2 root 10 meters per second. I can easily calculate the kinetic energy. So the kinetic energy will become half into mass into v square, that is half into, we can see mass is 1 into v square is 2 root 10 to the power 2. Okay, so it is half into 1 into 2 into 2 into 10. So you can calculate this as 20 joules. Okay, this is directly we can say, from this expression also we can say that kinetic energy is 20 joules, and by solving this, calculating the velocity also we can say that it will be 20 joules. Now it asks one more question, that does the velocity of the hammer depend on the mass of the hammer? Here we can see, when I am equating the two energies, in the kinetic and the potential, I can see that mass is getting cancelled from both the sides. So velocity, the expression for velocity contains only g, h and this 2. So the variable thing is only h, g is also a constant thing. So that's why we will say that velocity of hammer do not depend on the mass of hammer. Okay, the velocity is not dependent on the mass of hammer. Okay, you can note this. Okay, so we have solved question number 6. Now moving to the next one, question number 7. Calculate the energy possessed by a stone of mass 10 kg kept at a height of 5 meters. If 196 into 10 to the power 2 joules of energy were used to raise a 40 kg boy above the ground, then how high he would be raised? Okay, so question is related to the concept that when you raise some object in the air, okay, when you raise some object vertically, its potential energy will going to increase. So it says that there is a mass of 10 kg which is kept at a height of 5 meters. So we know that potential energy is equals to mgh. So the mass of the stone is 10 kgs, g is 9.8 and this is 5 meters. So we have to calculate it. This is the 9 5s are 45 and 5 8s are 40. So it is 49 joules. So the potential energy of this is the of stone. Okay. So this part is an easy part. You just simply have to write that what is the potential energy if an object is kept at 5 meters of height. Okay. The next part of this question is interesting. It says that if 196 into 10 to the power 2 joules of energy is required. See, when I am raising a body, what basically I am doing? We have learned that when I am raising a body, I am doing a work on this body, and whatever the work that I am doing will be converted to the potential energy and get stored inside this body. That's why if I take it to height, what will happen? Its potential energy increases, and with more speed it will start falling down. Okay, the kinetic energy and the potential energy, the relation that we have studied earlier. So here I will see that the potential energy, we know it is m into g into h. So we will say that the work done to raise an object will get stored in it in the form of potential energy. So that's why we will see that potential energy is equals to 196 into 10 to the power 2 joules. Okay, because the work done is stored, the energy, whatever the energy that I have spent is converted to work, and that work is stored again in the form of energy in the inside this body, in this boy. Okay, so the mass of the boy is given as 40 kgs. Okay, now by applying the mgh, potential energy is equals to mgh. PE is 196 into 100 is equals to mass is 40, G is 9.8, and H I have to calculate. So I can see that this 0 and this decimal will get cancelled. 98 is 2 times of 196, this 196 is 2 times of 98, then 2, this is 2 times, and this 2, and this is 50. So H will come out to be 50 meters. So the height at which this boy can be raised using this much energy, 196 into 10 to the power 2 joules, is 50 meters. So imagine if you have a brother or sister who is 40 kgs in weight, you can raise him up to 50 meters by utilizing an energy of 196 into 10 to the power 2 joules. Okay. So this is the question number 7. Now moving to the next one. Calculate the change that should be affected in the velocity of a body to maintain the same kinetic energy if the mass of the body is increased to 4 times, that is half the original, the increase to 4 times. Okay. What we can see that it says that when a body has some kinetic energy and I am increasing its mass to 4 times, then what will happen? What can be the velocity at that point of time? See, let us say the kinetic energy of a body is half mv square. So what does it mean? It means that a body of mass m is traveling with a speed of v, okay, which will going to have a kinetic energy of half mv square. Now if this m is changing to 4m, but new kinetic energy 1 should be equals to kinetic energy, means this one. If m is changing to 4m, it means that v should change to v1. Okay, what I am saying is if the mass is increased, let us say the new velocity becomes v1. So what can be the new velocity that we have to calculate? So by applying this relation, we can see that half 4m into v1 square is equals to half into m into v square. So you can see half and half will get cancelled, m and m will get cancelled. 4 v1 square is equals to v square. So it is 2 v1 is equals to v, that is v1 is equals to 1 upon 2 of velocity. Okay. So what we will say, that velocity should become half. The velocity should become half. Okay, and in that way we will get the that if mass is increased to 4 times, the kinetic energy will remain same if the velocity becomes half. Okay. Okay, so please note this. So we have done the 8th question. Now let's move to the 9th one. certain force acting on a 20 kg mass changes its velocity from 5 meters per second to 2 meters per second, then calculate the work done by the force. Okay, so it's an interesting question. It says a body is traveling with a speed of 5 meters per second initially. Okay, its mass is 20 kgs. Now when it is moving, some force is getting applied on this body. Some force is getting applied. Now due to that force, the velocity of this body, this 20 kg body, becomes 2 meters per second. Okay, although it is traveling in the same direction, but in this travel what we can see that velocity is getting decreased. So try to imagine that in which direction the force is getting applied. We can see that since the velocity is decreasing, it means the force is applied in opposite direction. This is the direction of application of force. So we have to calculate that what is the amount of work done that this force has to do. So to calculate that, what we will see that at this point of time the body has some kinetic energy, and at this point of time the body has some again kinetic energy. So we can see that energy can never be created nor be destroyed, the law of conservation of energy. By using that law we can say that the work done by force is equals to the change in kinetic energy. Okay, sorry, kinetic energy 2 minus kinetic energy 1. Okay, this value should come out to be negative because the force, the application of force is in this direction and this is the direction of the displacement. So force and displacement are in opposite directions. That's why we will see that the work done by this force would be a negative value. So we can see kinetic energy 2 means half into mass is 20 into v square means square of 2 minus half into 20 into square of 5. So this is 10, this is 4 and 10 is 40 minus this is 10, this 25 and 10 is 250. So this comes out to be minus 210 joules. This is the amount of work done by the force which is in the negative direction because the object is travelling in forward direction while the application of force is in reverse direction, that is a backward one. Okay, so this was the 9th question. Now moving to the next one. A mass of 10 kg is at a point A on a table. It is moved to point B. If the line joining A and B is horizontal, then what is the work done on the object by the gravitational force? Explain your answer. Okay, so the question is very interesting. Imagine a table, imagine a horizontal table on which I have kept a mass of 10 kgs. Let us say this is our horizontal table and here I have kept a mass of 10 kgs, okay, at point A. This is the point A. Now at this point of time, what is the direction of gravitational force? We can see that the direction of gravitational force is the downward. Okay, this is the force due to gravity. Now when this body, this 10 kg mass is moved from point A to point B, I am moving this object from point A to point B, that is in this direction horizontally I am moving it to some point B like this, 10 kg. Now at this point of time the direction of force is this, downwards. The gravitational force is acting downwards. Okay, I am applying the force to move this body, but in the question what is asking, that is what is the work done by the gravitational force, not by the person who is applying the force. We need to calculate the work done by the gravitational force. Okay, so what you can see here, that this body is moved by some distance, we do not know what is the distance, but throughout its journey what we can see, the direction of gravitational force is the downward while the motion is in this horizontal direction. So we can see that the gravitational force and the displacement are perpendicular to each other. So we can write here gravitational force and displacement are perpendicular to each other. Okay, both the things are perpendicular. So that's why the work done will be equals to F into S into cos theta. So cos theta, where theta will become 90 degrees. So this will give you 0. The work done would be 0. So gravitational force, the work done by the gravitational force is 0. Okay, and you can check in other way as well. You can see that work done is basically the change in potential energy also. Okay, I can write the work done in terms of potential energy as well. So work done is equals to change in potential energy, but at this point of time when the body is kept on the ground, okay, here the potential energy is 0. I am considering this as the ground. This is PE1, and here also I am